In this video, we will discuss estimating a population proportion. If we want to estimate a population proportion with a single value, the best estimate is the sample proportion p hat. Because p hat consists of a single value that is equivalent to a point on a line, it is called a point estimate. A point estimate is a single value used to estimate a population parameter. The sample proportion p hat is the best point estimate of the population proportion p. We use p hat as the point estimate of p because it is unbiased and it is the most consistent of the estimators that could be used. An unbiased estimator is a statistic that targets the value of the corresponding population parameter in the sense that the sampling distribution of the statistic has a mean that is equal to the corresponding population parameter. The statistic p hat targets the population parameter p. 1,487 adults were surveyed in a Gallup poll, and 43% of them said that they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. Because the sample proportion is the best point estimate of the population proportion, we conclude that the best point estimate of p is 0.43. If using the sample results to estimate the percentage of all adults who have a Facebook page, the best point estimate is 43%. In our example, we saw that 0.43 is our best point estimate of the population proportion p, but we have no indication of how good that best estimate is. A confidence interval gives us a much better sense of how good an estimate is. A confidence interval, or interval estimate, is a range, or an interval, of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated as CI. The confidence level is the probability 1 minus alpha, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. The confidence interval is also called the degree of confidence or the confidence coefficient. The table below shows the relationship between the confidence level and the corresponding value of alpha. The confidence level of 95% is the value used most often. For 90%, we would have corresponding value of alpha equals 0.10. For 95%, it's 0.05, and for 99%, it's 0.01. An example of a confidence interval found in a later example is the 0.95 or 95% confidence interval estimate of the population proportion p is 0.405 is less than p is less than 0.455. We must be careful to interpret confidence intervals correctly. There is a correct interpretation and many different and creative incorrect interpretations of the confidence interval 0.405 less than p, less than 0.455. Correct. We are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion p. This is a short and acceptable way of saying that if we were to select many different random samples of size 1,487 and construct the corresponding confidence interval, 95% of them would contain the population proportion p. In this correct interpretation, the confidence level of 95% refers to the success rate of the process used to estimate the population proportion. Wrong. There is a 95% chance that the true value of p will fall between 0.0405 and 0.455. This is wrong because p is a population parameter with a fixed value. It is not a random variable with values that vary. Wrong. 95% of sample proportions will fall between 0.405 and 0.455. This is wrong because the values of 0.405 and 0.455 result from one sample. They are not parameters describing the behavior of all samples. A confidence level of 95% tells us that the process we are using should, in the long run, result in confidence interval limits that contain the true proportion 95% of the time. Suppose that the true proportion of adults with Facebook pages is p equals 0.50. The figure below shows that 19 out of 20, or 95%, of different confidence intervals contain the assumed value of p equals 0.50. The figure is trying to tell this story. With a 95% confidence interval, we expect about 19 out of 20 confidence intervals to contain the true value of p. Critical values are based on the following observations. When certain requirements are met, the sampling distribution of sample proportions can be approximated by a normal distribution, as shown in the figure below. A z-score associated with a sample proportion has a probability of alpha over 2 of falling in the right tail portion of the figure. The z-score at the boundary of the right tail region is commonly denoted by z sub alpha over 2 and is referred to as a critical value because it is on the borderline separating z-scores that are significantly high. A critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. The number z sub alpha over 2 is a critical value that is a z-score with the property that it is at the border that separates an area of alpha over 2 in the right tail of the standard normal distribution. Find the critical value z sub alpha over 2 corresponding to a 95% confidence level. A 95% confidence level corresponds to alpha equals 0.05. So alpha sub over 2 is 0.025. The figure below shows that the area in each of the tails is alpha over 2 equals 0.025. We find z sub alpha over 2 equals 1.96 by noting that the cumulative area to its left must be 1 minus 0.025 or 0.975. We can use technology or refer to table A2 to find that the cumulative left area of 0.9750 corresponds to z equals 1.96. For a 95% confidence level, the critical value is therefore z sub alpha over 2 is 1.96. When data from a simple random sample are used to estimate a population proportion p, the difference between the sample proportion p hat and the population proportion p is an error. The maximum likely amount of that error is the margin of error, denoted by e. There is a probability of 1 minus alpha, such as 0.95, that the difference between p hat and p is e or less. The margin of error e is also called the maximum error of the estimate, and can be found by multiplying the critical value and the estimated standard deviation of sample proportions as shown below. E equals z sub alpha over 2 times the square root of p hat times q hat over n is the margin of error for proportions, where z sub alpha over 2 is the critical value and p hat times q hat over n is the estimated standard deviation of sample proportions. Excuse me. To construct a confidence interval for estimating a population proportion p, there are 3 requirements. First, the sample is a simple random sample. Second, the conditions for the binomial distribution are satisfied. There is a fixed number of trials. The trials are independent. There are 2 categories of outcomes, and the probabilities remain constant for each trial. And third, there are at least 5 successes and at least 5 failures. This requirement is a way to verify that NP is greater than or equal to 5 and NQ is greater than or equal to 5. So the normal distribution is a suitable approximation to the binomial distribution. Round off the confidence interval limits for P to 3 significant digits. Procedure for constructing a confidence interval for P. First, verify that the requirements are satisfied. Second, use table A2 or technology to find the critical value z sub alpha over 2 that corresponds to the desired confidence level. Third, evaluate the margin of error, E equals z sub alpha over 2 times the square root of p hat times q hat over n. Using the value of the calculated margin of error E and the value of the sample proportion p hat, find the values of the confidence interval limits, p hat minus E and p hat plus E. Substitute those values in the general format for the confidence interval. Fifth, round the resulting confidence interval limits to 3 significant digits. For example, recall that a Gallup poll of 1,487 adults showed that 43% of the respondents have Facebook pages. The sample results are n equals 1,487 and p hat equals 0.43. A, find the margin of error E that corresponds to a 95% confidence level, and B, find the 95% confidence interval estimate of the population proportion P. Requirement check. First, the polling methods used by the Gallup organization result in samples that can be considered to be simple random samples. Second, the conditions for binomial experiment are satisfied. And third, with 43% of the respondents having Facebook pages, the number with Facebook pages is 639, or 43% of 1,487. And if 639 of the 1,487 subjects have Facebook pages, the other 848 do not. So the number of successes and the number of failures are both at least 5. The check of requirements has been successfully completed. Manual calculation. We will find the confidence interval with manual calculations. The margin of error is found with z sub alpha over 2 equals 1.96, p hat equals 0.43, q hat equals 1 minus 0.43 equals 0.57, and n equals 1,487. So E is equal to 0.0251636. And that is the answer to part A. B, constructing the confidence interval is really easy now that we know the values of p hat and E. Substitute those values into the formula to obtain this result. P hat minus E is less than P hat plus E, which is 0.43 minus 0.251636 is less than P, which is less than 0.3 plus 0.251636. So 0.405 is less than P is less than 0.455 when rounded to 3 significant digits. We will pause here and continue in the next video.